right, everybody. We are into Unit 12. We're going to do embedded programming this week. So this is going to be our first of 2 coding weeks. And I think that this is week 16, maybe, which feels, and I at this point, I definitely could have lost track. But week 16, we're going to do embedded programming. And in our time together, we're going to sort of go over the basics of coding and what that is and how you do that with an Arduino, how to turn it into something useful. And then we're going to also go over the integration projects from the past week, which I'm real excited to hear about, to see what you made. I've got a thing that I've made some progress but didn't finish. And so we've got all sorts of things to talk about this week. It'll be really cool to see what's going on. But with that and without any further ado, let's hop right in to talk about embedded programming and what that looks like. So this week, we're going to talk about sort of conceptually what is embedded programming. And then the second half will be all about sort of the logistics of what does that look like in a real life application. So first off, we're going to answer the questions of what is embedded programming, what the heck is an Arduino, because we have played with them a little bit, but it's been a minute. What are the alternatives? How do these things interact with the world? How do they sense what's going on? And then we're going to tackle 5 core concepts of code. So if you've never coded before, this is sort of for you. And so there's a couple of people in our group that have definitely done some code. And so some of this may feel like it's not their jam. We've got fun projects for them to try. There's some level up things if they want to stay in the Arduino space. And learn how to level up their skill from that, because we have a deep wealth of things you can try here. But there's also plenty of other options. Like I was talking with Vincent, who's interested in figuring out how live streaming works on the internet, and that would be super cool and totally in the spirit of what we're up to. So there's lots of options, but we're gonna cover these things together this week for the lecture lesson part. But if you want to go off the rails and do some other stuff, you totally can. And just as much, we have completely step-by-step lessons that you can follow if this is totally brand new to you and you've never done it before, and you just want to ask and answer some questions. You can completely do that to make it make sense. So first up, what is embedded programming? And there's a lot of weird ways to think about and answer this, but it's putting code. It's code inside of a thing to make it run like you want it to. And so here are 3 key examples. A 3D printer totally has embedded programming. It's got lots and lots of code in its firmware to make it run and do what it does. A Keurig has embedded programming, right? There's some buttons. There's only a couple buttons, but it knows what to do when the lid is open, when you put in the K-cup. There's all sorts of little details and features that you might need to make a Keurig run well. And then sort of these crazy Rube Goldberg machine projects that are much more common in MakeHaven for things that get made here with lots of wild whatevers and things. The one that's pictured there was actually put together by a sophomore in high school who needed to work on something for a science Olympiad project. And so each one of these little blue rectangles is an Arduino that's all on its own, separate from everything else. So there's a ton of interesting things going on here if you wanted to try and figure out how to make things code and how to make that work. And these are just 3 examples, but there's tons of different varieties that you can look at. And if those are just 3 to get you started. But if you've ever are curious, it is not hard for the internet to spill out tons of examples of Arduino projects. You can go to Instructables, and there's an entire category on Instructables of Arduino projects specifically for Arduino, if you want to stay completely within this ecosystem. And they range all the way from beginner tutorials for fun time, make a cool thing that you'll take apart at the end of the day, all the way to was this someone's master's thesis, right? Where you cover the range of those things, wondering how it's going. They have various levels of instructions. It's totally user created content. So not all of them are easy to follow, but there's some really cool ones. The same goes for YouTube. There's a higher barrier to make a good video, but there's tons of videos out there about Arduino projects that are for beginners or just for advanced stuff. There's some really cool ones like how do you make this LED cube and all those sorts of things. There's tons of examples out there for Arduino projects. It does not take long. Let's see, I've got, I think if I hit escape here, I was pulling up This is from the Arduino. I was just sort of scrolling through. This is the Instructables website. So in here, monster fire truck from salvaged gravedigger power wheel, right? Like there's all sort, and these are all inside of the Arduino subspace. So this is tons of things that you can do. You could play practice Wordle on a tiny, tiny computer that's like half the size of a credit card, maybe. A fingerprint safe if you wanted to do one of those. There's like an 80s style home computer from scratch with Arduino components. Here's a glove that controls a robot. That's pretty cool. Like all of these crazy sorts of projects that you can just scroll through. Arduino water dispenser. That seems like a lot of fun. There's tons of different things that you can roll through and see sort of what crazy things people have made with Arduinos, what's possible to make with Arduino's Internet of Things mood tracker for the school or workday. That feels pretty useful, actually. There's all sorts of stuff. And so I would really encourage, if you haven't ever wandered around on the internet looking for things, hop on to page 5 and see what you get. There's still a pretty high production value in these thumbnails. So like I would suggest that you wander through. Oh, this is a fun one. I would love it if somebody made this clock. This is a hollow clock and those gears. You just download and print those designs, and then you follow the instructions for how to build this thing out. It's really cool. It's totally an Arduino project. Here's all the STLs. You just download and print them and a few other pieces. And then you get some of these really cheap stepper motors that we have in the back, and you can make yourself a super fun looking clock. It looks like great time. So there's all sorts of interesting projects that you can use to get things going. And Arduino covers quite a range on what this all looks like. Embedded programming in general has a ton of variety in it, but it's generally anything where you use a little bit of code to control something's actions. And of all of the skills that we have, of all the things that we're going to talk about together over our entire time, this is the one skill that I think gives you the most ability as like a secret superpower. When you can breathe life into the things that you've made so they can interact with the people around them, whether the people are in charge or they respond to people, it really adds a level of wow factor to the things that you've made that's hard to express. Like in art galleries, when there's interactive art, it drives people wild in a good way. When you've got something in your house that can change based on what's going on, or give you like weather updates that are live and without a problem, there's a ton of cool options to make those things work. There's all sorts of useful ways to use the things that you get in Arduino in lots of different contexts. Whether or not it is tied to an Arduino, just being able to think about that interaction between code and real life makes it much more useful. And then I think also it makes it something that's more interesting to learn. As you're learning to code, I don't know about you, but I've taken coding classes where it's like follow these instructions, and at the end you have a blinking square on a computer screen, which is fun. But it's much more fun if it's a blinking LED in real life in front of you on the table, right? And so it doesn't feel like a huge shift, but those sorts of transitions bring all of this more relevancy and get people to be excited about it. I've definitely been able to compare classrooms, official formal classrooms where you teach code and you teach embedded electronics, and the embedded electronics always builds up more hype and excitement. It's just the way that it goes. There's something tangible about it. So ultimately, we're trying to put code in a thing. And so embedded programming is anything that runs on simple logic. All of that is embedded programming. There's tons of ways that you can do it, but we're going to stick to Arduino as a general subsection of this space, not because it's the best, but because it's relatively cheap, it's a very open source, and it's close to the lowest logic available. And that means that you can really extend it and get close to, if you wanted to take something from Arduino to a product you'd sell as like a company, it's not a huge push. Whereas if you started with a microbits, you've got a few more layers that you have to figure out on the way. But in any case, this is super interesting. This is where you'd use code for logic. And I do have a caveat here. Sometimes you don't want code to run things, like for a hot air furnace. There's a controller board, but generally you want those to be somewhat locked in so that they only do one thing. They only have one behavior, and you don't want code or bugs in your code to be a problem there. So there are moments where you want to avoid it, but in general, code runs a lot of the world. So thinking about an Arduino is a nonprofit organization. They have hardware that's their thing, but it's an open source circuit board. And basically the board shown here on the right is entirely there so that you can get access to this one chip. I've heard that the name is an Italian pasta dish. I don't speak enough Italian to know if that's true or not, but it was invented in general by 3 Italians and a Spaniard. And they're still mostly made in Italy if you're buying the like main name brand Arduinos. Initially, this was invented by someone who taught at an art school who wanted their students to be able to make interactive art. And so they wanted to make the ability to make interactive art accessible to art students. And they didn't want to spend years teaching them electrical engineering. They wanted them to be able to figure it out in like a weekend or something. And so they built this board that solved all of the logistics. They wrote the software, they built the board so that even though you'd still need to learn how to code some, it was a much more approachable threshold than if you were trying carte blanche. And so basically all of this board here is getting you to have access to this chip in the middle. An ATmega 328P is what's at the core, the heart of an Arduino Uno. And essentially you've got this silver connector that lets you connect to the computer, maybe this black one for just power. And then all of these little pins on the side, they let you access the actual silver metal pins here on the side of the chip. Everything else is so that you can communicate. This part over here is so you can communicate to the computer. This little can keeps the chip at a precise timing. This is for power and management, and some of those things happen up there. You've got a couple headers for chip-to-chip communication. But in general, this is meant so that you can pretty quickly and easily take something from an idea, write just a little bit of code, and then get it up and running. It's not like it's totally cakewalk all the time, but it really lowers the threshold from what it was before Arduino existed. And so it's a super useful platform that we'll see lots of different things have been derived from. So let's say you have some idea, a magical device that when you put in a cup full of water and a plastic cup full of coffee grounds, it's going to make coffee for you. And all you need to do is press a couple buttons. Where do you do that? How do you get the code to go into the machine? How do you squeeze it into that little turquoise board so that it does what you want? We're going to go over 4 options. This is the first and the first party example of what you do. The Arduino IDE, this is part of what the team of Italians and a Spaniard made. They wrote up the Arduino IDE, which is right here, available for download at arduino.cc, and then probably English and software. You can download it for all of these different versions of operating systems. The source code is in active development. It's posted in public. It's open source. So you can see how that comes together. You can get the IDE 2.0 release candidate. If you want to go even more like bleeding edge Arduino, you can do that. There's all sorts of downloads and things. But for most people, what's going to be, I mean, for me on Windows, I would do one of these Windows apps. If you're a Linux or a Mac, you can totally use any of those. This is a completely viable way, and it makes let's see if I can just pull mine up. I totally have it installed, but getting it to open. There we go. Oh, it's opened on the other screen. Just a second. The Arduino IDE is this. So it's a program that runs standalone. It's got a whole bunch of examples built in. And so if I wanted to do this and do just basics, blink, this is the most iconic example written by people starting in 2014, 2016. Here's the example of just what it takes to blink a light on the Arduino. And so it's got just a few lines of code to make that happen. All of it is handled inside of this program that runs on my computer, and that makes the connections that you need to make to actually get code onto the Arduino. So that's one option. There's more options than just the Arduino IDE. If installing something on your computer is going to be difficult or impossible, then another option is create.arduino.cc. And this is totally done in the browser with an extension added in. And me as a teacher, this is a fantastic option because they have like classroom management. So if I am teaching in a high school, I can use create.arduino.cc, and then push out code to students, get code downloaded from them. This is very easy to share code with other people. So if you like this platform, you can totally use it. There's a bunch of good examples. This does have a free tier, but it also has a paid tier. So you've got to be conscious of that. It's a great product. It works really well. But there's a paid piece to it versus the installed one is totally free, because then your computer's doing the computation. Here you're paying someone's server to do work for you. So it's gonna, there's a little bit of a cost. It's cheap, but not always. If you get to a certain level, it's not free. This is one of my favorite ways to do Arduino, Duino.app. This is version 3, spun up from Chrome Duino. This is completely and totally in the browser. You don't need to install anything for this to run. So if you are working on a Chromebook all the time, you can 100% run this from a Chromebook. This is the best option for teachers. The high school class that I'm teaching right now, where students are learning Arduino, they use Duino.app. And so all of your code is run in the browser. There's nothing that needs to be installed. And so you can totally just do that. And so I'm going to open up Duino.app so that we can see what it looks like. And so here we go. There's a couple of things, but you go into code, you create a new project, and you just say, hello world, and create, and boom. I mean, you can name it whatever you want, but that's my project name is hello world. And then here's the same code that it takes to write this up. You can see it looks very similar. If I wanted this to work, you just need to select a device that's connected, and it'll do it directly from your browser. There's a JavaScript USB connection thing nowadays. So your browser can connect directly to your USB ports, for good or bad. And then when you have code like this, you send it to a server where it compiles your code, and then they send it back to you. The compile servers are all hosted by volunteers. This one that I'm using is hosted in Iowa. Maybe we should get MakeHaven to host their own compile server. We just need a little bit of compute time to host it on one of our machines. It's totally reasonable for us to do and set up. I think it's a Docker container. That's its own whole other discussion. But in here, you can use this to write code and have it compile it and run it completely and entirely from the browser. Even talk back and forth between the Arduino and the computer. This is a really cool thing that didn't exist last year. So the Arduino space is constantly evolving, and this is a really neat addition to have into how Arduinos work. So Arduino.app is really cool. And then if you're way hardcore and you already know how to code and you're just super excited about making it the most aggressively intense experience you can have, Platform.io is for you. This is, for projects in the space, I've used this for the sand CNC, which is downstairs somewhere, buried under some plants. But Platform.io is how most 3D printer firmwares actually get compiled. 3D printer brains are still basically just Arduino brains, but usually with a little bit more power and a lot more code in them. And so if you're already good at handling code and moving it around, this is probably the nicest way that you can reach the widest variety of boards, the widest variety of Arduinos. We're going to stay focused on Arduino Uno. It's the most common type. It's the one that we handed everybody during one of our earlier units when we did some soldering. But this system will allow for 800 types of boards to be programmed by Platform.io. And you do not need to use Arduino's infrastructure at all. You can build it completely from scratch if you're really interested in doing that. Platform.io is super powerful, and this is all I'm going to mention it because you know what you're doing if you're wandering into that territory. Totally. So what if there's 800 plus boards that Platform can work for? What are some of them? And so Arduino Uno is the main one for everybody who's a beginner. That 100% is the recommended path. To think about the Arduino Uno as the board that you're going to use. It's the friendliest. It's the one that all of the tutorials online are going to be about first. And then you can go other ways from there. Even if I'm doing a project that I know in the long run isn't going to use an Arduino Uno, I start with that because I always, me personally, I always have one sitting around in some drawer somewhere. And they're easy to swap in, and they're big enough that you can fit wires into the holes without needing to fight too hard. There are smaller versions, and these are shrunk, so they're not actually that small. But there are smaller versions like the Arduino Micro, and this is like to scale, these two. And there's a Nano and a few other versions. So there's some Nanos down here. Mega is about twice as big as the Uno, and this is what this is the actual type of Arduino that most 3D printer brains were based around when they first started. There's tons of options for how you can work with these and what sort of different things you can do, and this is all just within Arduino itself. The intro ones are great. If you really decide you love this and want to go deeper, the Arduino starter kit is actually a fun time. There's like 14 projects they'll walk you through. They give you all the stuff to make it happen. It's like $100, but if you're way into it, it's totally worth it because it's such a buttoned up package. And so there's tons of cool options in here, whether you want to go into the intro stuff or some of these advanced ones. There's lots of cool things. Now, there are plenty of alternatives, and I don't want to say that we're just an Arduino shop. There's Raspberry Pi and CircuitPython, and then there are the Adafruit Feather and microbits. There's tons of other ways that you can get to embedded programming, but we're going to just stay focused on Arduino because it keeps us all in one narrative. So the first of these alternatives is that you can actually just get rid of the Arduino itself and just directly program the chips. Somebody in last year's foundation totally did this. It's completely doable. And if you've already got some coding background, this is a really cool way to try and level up your skill. And if you're gonna build something that you want to sell, this is how you would do it. You'd build it around something like the ATtiny44, where an Arduino, you might buy an off-brand Arduino for maybe $7 or $12 online. The ATtiny44, this little tiny chip right here that looks like a short centipede, this thing is going to be more like 10 or 15 cents per chip, right? And so you can get really low in prices, even with the chip shortages. These chips are still relatively available if you're buying just the raw chips. And so these are the shortages, by the way. This is what there's a shortage of. But these particular ones are still relatively accessible because not a lot of people buy them in this chip form. So this is totally something you can do if you're interested. You can buy some ATtiny44s and we can use an Arduino to program chips. It's really cool, but it's a stretch. If you're interested in extending your embedded programming skills because you can already code, this is what I'd recommend you try and do this week. Another way that you can do embedded programming is Raspberry Pi, and this is a super fun one. In general, this is different from an Arduino. An Arduino isn't really a full computer. It's just like it's a logic controller, versus the Raspberry Pi is a real legitimate computer. You can log on to Linux, you can go on a web page, you can watch a YouTube video if it's a fast enough Raspberry Pi, but all of that is totally available through Raspberry Pi, and they've got tons of cool options. Essentially, I would choose a Raspberry Pi over an Arduino if I need a lot more processing power or if I need to be connected to the internet. The Raspberry Pi is much better at those things. The Arduino is much hardier and harder to break. Electrically, it's a lot more stable. It's a lot more robust. If I'm going to use a robotics application that isn't super computationally intensive, Arduino is probably better for that. But this Raspberry Pi is also fantastic. So totally worth looking at. We'll play with those a little bit later on in the course. Other microcontrollers in general, there's the Flora and the Gemma. So some of these are the Flora and Gemma. These are the wearable electronics. You can see they've got bigger holes for sewing. So you can sew those into position. Here's the Feather. And so this is a Feather with a Wi-Fi chip on it. The Microbit is this one. This is designed by the BBC for teaching kids in England about computer science. They're totally in front of us, by the way, in case you're curious. Here's a knockoff Arduino. Because the board is open source, a knockoff Arduino is completely and exactly the same. The inland ones you can buy from Micro Center, and there used to be a Micro Center close to where I lived in Cleveland. These were never more than $8 there. So like, this is a totally viable way to buy a knockoff Arduino Uno. If you're buying yourself a board online on Amazon or somewhere, and it's not Arduino brand, you can do it. If you want to buy Arduino brand to support what they're up to, you totally can, but they're like $30, $35, somewhere in there. But you're supporting the effort. And then there's these, which are sort of like Arduino derived little bits. These have a target age that goes all the way down to low elementary school. So you can do block code, you can do all sorts of things with those, and they don't have fiddly wire bits that you have to plug into each other. So if you're having hard times with fine motor skills, these actually have magnets and sort of snap themselves together and auto seat in the perfect way. They're really cool for people with fine motor issues, but they're also a more expensive option because they solve a lot of problems for you. but really cool. So we've got all of these different weird options. How does this thing actually interact with the world is a reasonable question. And it boils down to this crazy diagram, which is a lot to look at. And this is something that you should probably see once. Maybe you'll know that it exists and you can reference it if you need to. But this is what it's able to do. The chip, you basically leave in the board. You don't do anything with that specifically. The way that you interact with the chip and the board is by getting access through all of these pins that are on the side. And then what's listed here on the right and on the left, those are all of the different things that are going on. Like in the pink here, in the sort of pinkish color, this is what they're labeled in the IDE. So this is what they're labeled in the development environment. So if you say, I want pin 3 to blink an LED, you say pin 3, and it's referring to this spot on the actual board. But there's a bunch of other things that are going on. Like it is got this particular code for its existence deeper down in the software. It can pulse width modulate. You can describe it as being a PC int and do all sorts of stuff. There's tons of different weird options that you can do. Over here, you've got analog pins that you can play with. And so these are analog pins along here, or you can treat them like digital pins. So these ones can measure voltages instead of just read off or on, which is fascinating. But looking at this whole diagram is not something you're going to wrap around your head in aggregate, or wrap your head around in aggregate. But in the moment when you need to use it, you might want to look up and say, can I use this pin for this thing, right? Like only 6 of them will do pulse width modulation. And so knowing which 6 it is, looking up the diagram can be really helpful. And then, some of the other details you might from time to time want to look at. But this is a map for how it actually interacts with the world. And it's a lot. It's a lot to take in. You can't learn it all at once. But if you wanted to, here's the pin for the actual chip. Basically, these completely mimic this. They're just mapped through traces and wires embedded into the circuit board. So they come out in this format that's standard across all Arduinos. So what the heck is all of this? An Arduino, in its essence, it does the same thing that all sorts of digital electronics do. They make sense of a messy, all over the place world. If you really want to get down into the weeds about this, there's a fantastic article about analog versus digital in how this works. Analog things like clocks and meters and joysticks, those have sort of in-between values where you've got the ability to be one thing or the other, where you look at the dial and if you want to know exactly what time it is, how precisely is it from one mark on the dial to the next, those sorts of issues start to matter. In a digital system, you find your way to make this a little bit more sensible because it takes that entire analog system and smooths it out. The most common way that adults in our age group might have interacted with this is the transition from analog to digital radio or analog to digital TV. When they were broadcasting analog signals, the heights of the peaks and valleys mattered, right? You can imagine watching Friends and getting it on an analog TV signal. And if the waveform wasn't exactly right, it would not look right. Or if you're listening to somebody on the radio and the waveform isn't quite as tall, the music isn't quite as loud. And so any degradation in your signal, it starts to become pretty noticeable. The analog systems worked great for a long time, but we realized that there's some robustness in digital, where instead of being a weird wave, you could be high and low. And if you get a signal that's a high, it comes in as a digital 1. And if it comes in as a low, it's a digital 0. And then you're sending messages in 1s and 0s, which leads to a lot less ambiguity in a signal. It leads to less static. You might notice that when you made the switch, that your signals were often clearer, and they were either clear and totally fine, or they would just cut out. Digital signals very often do that, where you can sort of interloop. You can figure out what's going on if you miss one signal or the other. There's some really cool stuff. I could go for a long time on this specific topic because it's fascinating. But the big thing is that an Arduino can interpret messy data in the world and turn it into something that's clean and mathematical. And so it can organize sort of the chaos into something that's really useful. It does that by measuring voltages and doing all sorts of cool electrical stuff that you can get a whole degree in if you want, but that's not the point of this discussion. So we'll just keep on moving. So what is the logistics? How the heck do you use any of this? What is it going to be used for, and how do you get going in just a couple of hours? Because although it can take you years to become masterful at this, most people just want to figure out how to get in and get going. And there's a whole bunch of ways that you can do it. My genuine response to this question of how do you get started is honestly to hop back in and do this. Like hop in and grab one of these tutorials and just follow it. Like start to do a lot of these, if we go back into these and we look at Arduino, we might even be able to do popular or winners, or like starter Arduino projects. And we search for these, you're going to get a whole set of projects that are much more approachable for a beginner, that give you what's going on. Or the other place that we could go is YouTube, Jeremy Blum. This guy had a whole bunch of YouTube tutorials that we suggested earlier on. And in here, he's got here's exploring Arduino. So you can go through tons of tutorials like these if you wanted to get started from the very beginning. I don't need an ad. But you can absolutely get started by following along with some tutorials. That is a fantastic way to get started for how do you really make sure that you're engaged in this content. But in terms of like logistics, how do you do it? Just how do you connect it to a computer is really tricky. And so what I've got here is a collection of actual legitimate steps that you'd want to use. So these are going to be in the slides. They're things that you can come back to. We're at 7:38 right now, and I don't know how long that is in, maybe about a half an hour into the video. But in this, you're going to want to take a look at how do you actually install and get started with your Arduino to make it work. So if you installed this Arduino IDE, you'll go get it from the website. Then the easiest thing to do is to plug an Arduino into your computer. And I have one nearby, but maybe I can get to it a little bit more easily without. And so here is an Arduino IDE. And if I click up here, if you plug in an Arduino, you'll need to choose some settings up here in this menu. So this is where you choose your board. It should be defaulted to Arduino Uno. If for some reason you install the European version, it might be called a Genuino Uno, but Arduino is the American name. And then you'll choose your port. So it'll go through and you'll have a connection where you can connect to the Arduino. But in here, you choose your tools, go to board, and then to port, and it'll get connected, no problem. So plug an Arduino into your USB port and then open the IDE. That'll get you to where you're going to actually make the connection. And the software that you installed. From there, you can just upload your test code. Ooh, I do have a cord. So here's a project I'm sort of lugging by. Maybe I'll be able to get plugged in, maybe not. And so when you're plugging in an Arduino to a computer, you want to make sure that you've got a connection that is nice and solid. And so I'm just plugging one in to see if we can get it to interact correctly on the screen. And it might work, it might not work. Technical demos in the moment are always tricky. But in here, you go to Tools and Port. I'm choosing COM3. On a Windows machine, they're going to be called COM ports. On a Linux machine, there's something crazy. And on a Mac, it usually auto connects. But you'll have to be careful to whatever yours is. So I can do this and I can upload. I can even do examples, communication, and ASCII table. I can upload this particular program. This is going to print back to me all the letters in the alphabet. And when I do this, you can see down here it's compiling, and then it's uploading the sketch to my Arduino. And then if I click on this, this is the serial monitor, and it is spitting back to me all of the characters in the alphabet. And so I can totally do this again. And if I hit upload one more time, it will do that again from the start. And so popping in to the COM port, it's running through all of the letters in the ASCII list. And so that's the Arduino my computer talks to the Arduino, and then the Arduino talks back to my computer. All of that is handled by the Arduino IDE. There's some trickiness to that, a little bit of clicks and magic to make that work, but it's not too bad to get it up and running with the Arduino program, because it's the one thing it's specifically designed to do. So that works great. This works really well. And so if you're doing any computer, this is what I would recommend you do for any beginner. Start with the Arduino IDE. The browser and browser extension setup, this you'll need to go to Arduino Create and make an online account. There's a browser extension you have to install, plug an Arduino into your computer's USB port, verify that there's a connection, and then you upload test code and start your project. It's also pretty straightforward and it guides you through. Websites are really good at being able to do that. So it'll give you some guidance on how to make this work. But it's not what we're going to step through. But the Chromeduino setup is really nice. And so I did plug in. Here's Chromeduino. And so here's that example code that I had pulled up before. And all I need to do now, I'm on this page. We sort of saw how that started. I can go to select device, and maybe I need to disconnect it from there we go. We're going to connect. It was connected to the IDE, and now it's connected here. So I've got a serial port selected, board Arduino Uno. And if I compile and upload, this sends the code that's in this program off to some server somewhere. They handle it, and they upload it back to my board. And if I go to the serial monitor, I'm getting back information. So on the actual Arduino, it's blinking an LED, it's blinking a light, which is pretty cool. But it is telling me that it's connected by giving me feedback here. And so there's plenty of logistics, but it can be that quick to change things. And if I want this to happen faster, this is it's going to be a little nuanced, a little hard to tell, but this delay is delay for a whole second. If I just change it to 100, that's for 1/10 of a second. And if I do this, you should see that the high lows come back in a lot faster. So just a little bit of futzing around with the code, and now you're able to make some adjustments and really see how this works. So there's a ton of really cool options within this system and multiple ways to get code to your Arduino. So if you find that one is not working for you, let me know and I can help you get it sorted so that it works for you. There's tons of ways to make this work. A lot more now than there used to be. So those are sort of the big ideas of like what is an Arduino? How does embedded programming work? How do you find cool projects that you want to make? There's tons of options there. But the big question is okay, so now you want to do something. You've maybe got it figured out how to connect it and just like click upload, but now you need to figure out how the code part works. And so this is a key part of getting to understand. This is where someone who's never coded before, we're in it for you in case this is what you're up for. So we're going to start with the minimum required. What do you need so that it will at least load it to your Arduino? What's the bare minimum you need? And then we're going to talk about these 5 things. And while we're doing that, I want to be pretty clear. These exist as a host of lessons that I've put together. They've shifted around a bit over time, but if you look up Corey Rice Scopes Arduino, and I posted this directly into the Foundations chat, so you might be able to get to it there. Here's that board again, the one that the sophomore girl made. But here is this lesson laid out with all of its contents, free for the world to use. You can totally follow this. These are all the things with a little bit of intro. But we're going to basically spend our time, if you look at this, the first one is using Arduino for math. And so these are lessons that were intended originally, and I mean this in all of the best sorts of ways. These were originally intended for high schoolers who are fairly self-starters for learning how this works. And what that means is that they're approachable for everybody, right? As long as you're able to play along, you sort of do the game, there's going to be, these documents are very self-guided. And so if you follow along, it's going to ask you the right questions to move forward. So you'll totally be able to figure it out by following along with these. We're going to talk our way through it first. So the absolute minimum thing that you must have to get any Arduino sketch to work is a void setup and a void loop. Those are functions. There's some details that go along with that, but void setup and void loop have to be there in order for you to get things to work. And so we'll look at that in just a second, but I do love the meme. There's 2 states of learning to program or being a programmer. There's moments where you feel like you understand everything and the world is your oyster. And then I definitely spend more time feeling like that dog, or I have no clue what's going on. So that is how it goes. There's nothing wrong with that. You're going to feel both of those feelings as you get better at this, but just getting started with how to do this coding business, here is the example, the minimum example that you need. And in order for this to work, I can check this little checkbox up here. and that's going to verify my code and I don't get any errors. This thing down here is really helpful to see if you've got anything that breaks. And if it doesn't tell me a whole lot of things, then I'm good. Then in general, it means that I've got what I need and it's going to work. So avoid setup and avoid loop is all that you need. If I got rid of either of these, and a good way to get rid of things quickly is to control/, highlight it and hit control/ on the keyboard. And now there's not a void setup. If I do this and compile again, oh, it's asking me to save, which I don't want to do. And so I'm going to hit cancel. It's going to do this, and you can see I got a whole bunch of errors. That basically you have to have a void setup and a void loop, or else it won't work. And the other thing is that they have to be there, and all of their punctuation needs to be right. Now, one of the things about this that can be really frustrating to a beginner is getting the punctuation. And so I do want to also share that there's a workaround if you're trying to learn how to code and the punctuation is just not doing it for you. If that's the case, you can totally get out of even the punctuation part if you like want to get at the ideas, but not that. You can hop into, this is Tinkercad, which we're going to look at as a 3D modeling software, but inside of Tinkercad, buried in a little bit deeper, let's sort of back out and find our way. If you log into Tinkercad, you get this account, and by default, you're looking at 3D designs, where you can 3-dimensionally design things in here. It's a cool 3-dimensional design tool in the browser. But if you click on circuits, they have this whole area where you can create circuits and play around inside of the browser, simulating an Arduino and coding it with block code. And if you're just trying to learn how this works and you're feeling like nothing's happening, a lot of people will be comforted by learning to code with this sort of a format, where you can have control loops and things that happen here. You don't have to worry about any punctuation at all. It's sort of drag and drop to make it code. Even better, they do blocks in code. So you draw your pictures of code over here, and then it turns it directly into the code that you can copy paste into the Arduino. So you can either do that, or you can directly download the program, and then you can use it from there. So the bare minimum is that you need to have a void setup, which is right here, and it goes from lines 11 to 17 in this program, and a void loop, and here it goes from 19 to 31. And so that is totally the minimum that it takes to make it run. You can get to it lots of different ways, but that's what it takes just to get started. And so let's not lose the slides that we're presenting. There we go. Yep. So that's the absolute minimum you need to get started. But when you're starting to program, the first thing you're going to need to start to do is say, well, I want to do work on things. And the Arduino is going to need to remember what it is that you're working on. So the first thing that you run into is memory. And memory is memory is a mind-blowing concept in general, like whether it's people or computer chips. But here is an SRAM zoomed in really, really closely. So this is what a microcontroller's memory physically looks like with a high zoom magnification. There's actual little pieces in there that are remembering the ones and zeros, which is bonkers. But inside of the memory on an Arduino, the easiest way to learn these processes is by doing a little bit of math. And so some of this is going to feel like old school math terms being brought back. Like if I want a variable that's named A, the letter A is its name, and its value is 35, I'll need to call it an integer. And an integer, you learned in math a long time ago, is any number that's like 1, 2, 3, 4, 5. A number, not 2.5, just 2 or 3, like a regular old number that is a whole round number. So those are integers. An int covers a certain range, right? There's a certain limit to how much memory gets allocated when you ask the computer to have an int for you. And all of this has some detail, some subtlety to it, things that it takes some practice to learn, like because it only allocates so much memory up to here. If I have this number, 32,766, maybe one less, and I add 2, weird things start to happen. And so for the examples that were all shared in Slack, and let me pull up some of those. I've got in here, let's go take a look at pull this to the surface. It's opening things. We're getting there slowly. Inside of here, this is a big guiding document that's going to walk you through all of these explorations. And it's got tons of example code. This is me writing prolifically during some crazy winter month when there was not much to do. So I've written a lot about this, and it might be helpful, it may not. These are all the different types of variables that you can have, and you can see that they have their ranges. Ints go from 32,000 to 32,000. That's helpful, but not very large. But a long is really useful. That goes from -2 billion to +2 billion. And if those were counted once, if you counted once a second for 2 billion for the 4 billion seconds, I need to double check this. But you're talking about longer, that's the Earth has only been around for 4 billion years, right? So it's a lot. You got a lot of numbers there. It's a very big value. You can use it for plenty of things without worrying about this weird problem that happens with the 32,000. So all of these are different interesting things that the work that you would do sort of wanders you through. You can do mathematical operations. Here are the 5 most common mathematical operations on our Arduino: addition, subtraction, multiplication, division. Modulo is a fun one. Most people know all of these as you work through your math, but modulo is often new to someone who hasn't programmed before. But if you did long division, and only some of us might be, not everybody now does long division in school, but if you did, and you remember remainder 3, 35 divided by 4 has a remainder of 3. Modulo is just responding with whatever the remainder is from long division, which is interesting. Like, it's useful if you have something that wants to happen every 4th time in a cycle. You count your way through the loop, and every 4th time your modulo would be equal 0 because you'd have a remainder 0 when you go up to the next one. It's fascinating, but it's also a little tricky. So don't worry too much about it. In any case, there's a host of things that'll have you walk through what are those different versions. The like document that you could follow will have you explore, how about the memory? What happens when you roll over? What's the difference when you change this line here that's got C equals A plus B? This is where you change the plus to a minus, or the plus to a multiply, or plus to modulo. This is where the math actually happens. And so you start to get familiar with how that's built up so that you can do the calculations that you want. And so that's a neat way to start to explore it. Then once you get past that, because math feels like a very approachable thing for lots of people, you basically don't change the sketch that's there on screen very much. You're just sort of playing with memory and how that works and sort of the quirks of that. That's the first thing that you should do, just to get a sense of what are the basic feelings. You'll have a real good intuitive sense for what the math is going to look like, even if you lug out a calculator to double check your Arduino. It's going to be totally fine. That's a great place to get started. It's a good point for people. Next up is Booleans. This is probably more fundamental to how computers work with their ones and zeros. And this is essentially the core of ones and zeros. Boolean algebra, Boolean logic is something that we've seen actually as a theme already. This is from our graphic design, our vector design units, where we'd have these different paths that you could do in Inkscape. But ones and zeros are really, really common, where you talk about ands and ors. Like, a lot of the time you might have 2 inputs to a function and then want to know the output. And if they're added by Boolean logic, then if both of them are off, then your output is off. And if either one of them is on or true or a 1, then the output is a 1. And if both of them are true, then the output's a 1. And there's a lot of reason to think about it like this light bulb circuit. And maybe circuit diagrams are your jam, maybe they're not. But if either of these 2 switches are closed, the light turns on. But it only takes one. If both of them are closed, it'll still be on. It can't be any more on than on. And so that's an interesting effect. This is a little esoteric at the beginning, but once you get the hang of it, it's not too bad. The easiest way to see this is with the if statement. And so if you've done any work in a spreadsheet, you might have played around with the if statement. If the returns for the quarter are above this point, turn it red, or turn it green. And if the returns are below this point for the quarter, turn it red, right? So you can totally play around with that. And here is where that logic comes into play. So in the code of an Arduino, you'd say something like if, and it judges whatever's in the parentheses. So if A is true, then you do whatever it says. Otherwise, or else, then you should do this other thing. So you have a variable named A, and it's saved as true. And so since it's going to judge the value of A, and A is true, it's going to say back to you, I like cookies. And if you change the value up here to false, it'll judge it again and say back to you, ice cream is nice, right? So this becomes a way to sort of probe the edges of how that Boolean stuff works, where you have if and else. You don't always have to have an else. You start to think about curly braces as you work through these, sort of how do you set limits on things? Those details become really helpful. And this if statement, if else statement is really restricted from within this pink bubble. So it's good to start to see those details as you're wandering through. You can also add in more operators. So in this case, we've got A and B, two variables. They're Booleans, which means they can only be true or false, high or low, 1 or 0. They can only be a yes or a no. And so in this case, you're not just judging the value of one of them, you're sort of taking two of them together. So if A and B evaluate to true, so if either of them or both of them are true, then it will tell you I like cookies. And if both of them are false, and only if both of them are false, it'll say ice cream is nice, right? So you start to get a sense for how those structural operators are working. And it's absolutely weird to do in this context. We're doing this without any things happening, but you can imagine sort of a simple machine where if there's two buttons, maybe you want somebody to have to press two buttons at once before you let them fire a rocket, right? Something like that, where there's a perfectly good reason why the code should be written in such a way that you need both of these things to be true, or just one of them can be true, and that's fine. So you can start to set up those relationships by understanding these connections. Then there's while loops. These are interesting. They can also be the fastest way to break an Arduino, but they're super helpful. And the comparison is here with the Roadrunner and Wile E. Coyote. While not at the edge, run. And in this case, do run, but while not at the edge. So there's a little bit of nuance. It's I don't know, it's a fun coder joke. If you're way into the code pieces, it's neato. But basically, he's checking to see if he's at the edge all the time, and if he's not, then he keeps running. He's running, and then if he realizes he's at the edge, he stops, which is exactly how these two relate to each other all the time. While loops are things that you can absolutely set up. So while true, this is a sort of a weird one. I'm just saying that it's always true. So while true, say hello world and wait a second, and then say hello world and then wait a second. You can set up a loop that it will live in for forever. And actually, that's what the void loop is, right? The void loop is a while true loop. It's going to be in this loop for forever. Void setup is what happens at the beginning of powering on an Arduino, and void loop happens forever after the setup. So the void loop is a while true loop. This is just a chance to play with it. And you'll see that if you loaded this particular sketch, it would just say hello world. It would never get to good night moon. It just doesn't make it that far in the program. It's stuck for forever. This is how you can write a program that sort of breaks in weird ways. It wouldn't throw any flags that something's broken, but it wouldn't do what you expect it to. And so this is an interesting thing to think about when you're looking at while loops, but they can be helpful. A more common case is you might say something like, I'm going to track a value and it's going to change. And as long as it's under a certain amount, I want to do something. Like on a 3D printer. One thing that we track when the 3D printer is getting ready to start is we look at how warm is the bed. And if the bed isn't warm enough, or the heated bed on the 3D printer, then you want to not print. You want to hold it in a holding position until it's warm enough to actually do the printing. And so there's a while the bed is under a certain temperature, then it stays in the heating mode until it reaches that temperature, and then it can start to do more actions. So these are really helpful if you have a time where you want it to do something repeatedly until you hit a certain number. They can be a really powerful tool. You'll just need to make sure that you have a strategy to exit them when you want to. In this case, it'll judge if the variable x is less than 10 every time it starts the loop, and then each time it goes through, it adds 1. So this is a fun one to do. It'll print out the values 0 to 9, and then when it gets to 10, it will be equal to 10, not less than 10, and then it exits the loop and says exited the loop. So, they're simple little programs to get started, but that's how you get going. From there, you'll really quickly get into other things. And as you get into more complicated stuff, you'll want to start to think about data, all right? And how you handle data usually comes in lists. Most of you are going to be experienced with lists and spreadsheets and those sorts of things. And so comma separated values, CSV files, are totally a bread and butter of a spreadsheet. And so across there, you might have a set of comma separated values, and then want to act on each one of them individually. Data arrays are a really structured format for your data so that you can address things that are going on in a list. And I could talk about this for a long time, but basically each one of these has an address to it. So this is in position 0, position 1, 2, 3, and 4. And so if you take this particular sketch, you're going to get sort of an action that comes out as a result. There, you need to know how to read from an array, how to write to an array, and you'll get to explore that a little bit to make sense of it. But having lists of numbers is really helpful if you want to loop across them. And so a for loop, which is hard to have a picture for, to be clear, a for loop really works well in tandem with data arrays. Because if you have a list of data, you may want to act on that list and say, do this thing each time you pass through a list item. And so for loops are the most complicated structure we've seen so far, but they're still not too bad. A for loop happens inside of this pink circle, and it's going to be something that happens. I like to think of them as a stopped loop, as a loop that has a planned exit. So in this case, we have a for loop that says you've got this variable I. We're going to start its value at 1. And as long as I is less than 8, I want you to do whatever's in this loop. And then when you finish, when you get to the bottom, after the delay 1000, I want you to up its value by 1. So the first time through, it'll print a 1. It'll say going through the loop time 1. Wait a second. Then it'll go through the loop time 2. Wait a second. 3, 4, 5, 6, 7. And then when it gets to 8, this second one, the condition will not be true anymore. So Wile E. Coyote will have run off the edge of the cliff, or the value is just equal to 8. It's not less than 8 anymore. Then it exits the for loop and it goes on to finish the loop and does that. So this is another one of those simple examples that gets you to play around with these things. And it just is a chance to explore what this looks like. It's really helpful if you've got a whole series of LEDs. The most common place that any of us is going to get to use a for loop for the first time is in having 6 or 7 LEDs, right? So if you have a bunch of LEDs, they're connected to your Arduino pins that are down the side of the Arduino board. All of a sudden, you're going to want to play with them and get them to all light up. So if you have a list of them, you can do for loops to act on the list, set them up as outputs, get them to blink, do all sorts of interesting things, and it can be super useful. Hopping back over to here, if we go to Tinkercad and look at some of these examples inside of circuits, over here, we can tinker this thing. And here there's 4 LEDs, right? So having 4 LEDs and looking at the code for this, here's lists of lists. So this is trying to do crazy array things for all of it. This was thinking about someone's animation, but you can totally play around and have lists of lists, getting it to be frame by frame. So you can see it's sort of doing this animation here, getting them to light up in different ways and different patterns. So you can have for loops like this one and this one acting on information that's stored in lists or in lists of lists. You can go way down this wormhole. And I just want to be clear, this is its own entire category of careers. So don't feel like you're going to become an expert in a week by any stretch. But it gives you a chance to get in and play, just to start to think about, how does this array work? How do we work with those? How do we make lists of lists into something that's useful? All of that is something that you can totally start to explore. Just getting, you're dipping your toes in, right? You're getting started. And so as you get going, the first of these, here's another example. Once you've got lots of things, starting to think about arrays as a way to control stuff like this, where you've got, a bunch of LEDs, maybe a bunch of potentiometers, they become really useful. Do I even have code written for this? No, basically. But you can see that this code is not going to be adequate to run all of this. I'm going to have to think about, what do I do with all 6 of these, with all 4 of those, and how do I make that into something useful? It'll be a lot easier to write code that handles them in lists and for loops than to handle them all one by one. So those are our 5 concepts that I would really like it if you explored this week. So hopping back through, looking at what all these were, that's the minimum required: math, memory, and variables, Boolean logic, while loops, and data arrays, and for loops. And if we're going all the way back to this, these are actually things that you can pop in, and they're sort of guided documents that say, here's a sketch. load this onto your Arduino. And if you do this and we pop into the Arduino IDE or go to Arduino.app, we can stop this and just copy, oops, click in here and paste in that code. Here's the code that was just there. We can compile this and upload it. This is our two values. So this is what I'm hoping that you get a chance to do, is take this, and it's a little, it feels a little simple, but if we do this and we upload our code, I suppose I could have probably reset it some other way. This is going to take 35 and add it to 4, and I should get a response back from the Arduino at some point. Oh, if I go to the right baud rate, to this baud rate, there's connection speeds, there's a couple of details, but 39. Haha, that's it. We did it. It feels, there's moments where it can feel like a weird, underwhelming experience, but there's also moments where seeing a number like 39 spill out of something that you've written, you can feel like an absolute and total genius. So the hope is that you get a chance to do some of that this week. And this is just your first steps in. If you want to follow those instructions completely to the letter, they're totally there. You copy the code in, you sort of answer the questions to say what works. This screenshot goes here. That's more for when I tell high schoolers they have to do this and they begrudgingly follow along. You guys in no way need to submit screenshots back to me, but it's good to like at least have explored these ideas and walk through. And so there's different code that you can play around with, concepts that it walks you through. They're really useful for getting to some of the ideas. Like here's subtraction, or here's longer addition, right? Where you play around with what happens with those variable lengths. All of that is stepped down in these programs. So this is going to do Arduino for math, Boolean logic, while loops, arrays, for loops. And then there's more, right? There's 5 more for next week. So if you really start to go strong, you can totally do this. If you can tell right now that that is not for you, that's totally fine. Instead, maybe you want to follow along with a video, watch a video instead of read the content of that. Any of those are totally reasonable options for what you want to do this week. Or maybe you bail totally on the whole thing, and instead of doing any of this, you are just going to be thinking about trying to play around on your own or following someone else's tutorial. All of those are totally on the table for this week. We just want to give you a bunch of options. So one of the things that you'll definitely want to think about as you're writing your code or fiddling with code is there's things that you can troubleshoot that may make you feel like your brain is alternately very large and small, like this one in a hand. I don't know where that came from, but it's great. So the semicolon at the end of a line of code can be really frustrating. If you get an error in the Arduino IDE, it's probably because a semicolon's gone or a bracket. If an Arduino library is not found, that should not be an error in the first 5 of the lessons. But if you're trying to struggle through a project that you found online, this can be a pinch point real quick. If you forget to identify the USB port, which I had to do in this app down here, I had to select it as the COM3. If you forget to do that, or specifically for Arduino.app, every so often, everything will look good, but it won't work. Just refresh the page and it'll work again. It's one of the weird things about it being in a browser. Variable scope issues. This is a whole concept for next week. This can be tricky for a new coder. Variables only live in the smallest container that they can. So you have to be careful about where you define them. The serial baud rate, and I ran into that in this video. That was when I was playing with this number down here. You go into serial, we have this work, and we do this. The baud rate is set up. Oh, error. Look at that. I had an error already. Where you do this and your serial monitor comes back to you. That's doing it. We go to the monitor. This is the connection speed. So your Arduino and your computer need to talk to each other at the same speed. They have to agree on this. I have it set up in serial begin 9600, and my monitor has to match that number. So that's a point that can get confusing if you don't know what's going on. And then forgetting to plug in the Arduino. Totally reasonable, happens to everybody. Or one of the things that I really don't like is if you have a no data USB cable where it's just power. This is probably not going to happen. I feel like most phones have switched over to USB-C, but there are still some USB cords out there that are terrible. And if you find that you have power only USB, throw it away. Cut it in half, throw it away. Don't keep it. It's not worth it. They're very cheap. Get a good one. So what are your goals for the week? The next steps, pick through the example sketches in the Arduino IDE. If you install the Arduino IDE and go through it, file, examples, and this is a gold mine. I myself learned by watching the Jeremy Bloom videos and then reading through these. These are really well documented. They walk you through, like, here's digital. You might need to do a debounce where you have a button and you need to know how to make sure the button works the way that you want it to, or maybe you're doing file, examples, digital, blink without delay. Maybe you realize that delay is a problem, and so you want to learn how to get around having to use a delay because they pause everything on the Arduino. Maybe you want to learn how to outsmart that part of it. And so those examples can be really, really helpful for trying to get those things to work. Play around with simple changes. Just trying to find what you understand and exploring the boundary of that can be really helpful. Try hooking up some LEDs. There's tons of great tutorials about how to actually connect them. There's one built in on pin 13, but you can totally hook up your own, or on the learning boards, if you pop that shield onto your Arduino, you have LEDs then on pins 9, 10, 11, and 8 that you can play with. So those are fun. Although the 9, 10, 11, they're inverted. So you've got to turn them off to turn them on, which is confusing. There's a style guide. So if you want to write neat code, you want to try and conform to their format. If you're into how do you write code the way it should be written, there's a style guide to help you with that. You can try and find ways to make the same program with as few repeated lines as possible, or just keep wandering through. There's a ton of ways to get better at this week. And this is going to feel probably the most like homework, because it's literally homework that I'm sharing with you for lessons. But this is the sort of eat your vegetables that we need to do before you can have any pudding. How can you have any pudding before you eat your meat? It's very that sort of Pink Floyd. For some people find this fascinating and go way into it. If you all of a sudden realize that you love coding, get a job doing it. Go get a degree. There's a massive shortage. This pays really well. If you're interested and want to go further, we can help make sure that you head in the right direction to make yourself a big life change for this. So there's tons of cool things to do, to explore. I want you to hop in and do all of that. Looking at design things here, you can play around. If the code itself sounds terrible, you can do it all in blocks inside of Tinkercad and then download and install to an Arduino. Like for this, I don't have a servo right now, but if I grab this and put it into Arduino.app here, closing this, I can paste it in, and this will compile and not throw any errors, right? Tinkercad writes the code. I need to include a library. There's some details to that we can get to. It's in here. You go in and you say servo, but all of those little details, they come one at a time, right? They're things that you add in as you go. And as you get better, as you practice that more and more, there you go. Installed servo, success, done. It's working. And my code is up and running without a glitch. So all of those little details, they're just little pieces that you add in. The first 5 steps that you should take should be going after math, Booleans. Then you start to do while loops, arrays, and for loops. Those are a great place to get started if you've never done it before, or you want to have sort of a guided tour. That's the way to do it. If you just want to hop in and make something, Instructables is fantastic. Would totally recommend. And we're going to be doing this week. We're going to do it again next week. And I'll be around to help on Thursday and on Sunday, no problem. We also have Coleman Merchant, is electronics facilitator. He's going to be around on Wednesday. We're cranking out the details, but he might be our co-instructor for this section. So if you want to play around with him, that means that Wednesday, Thursday, and Sunday are good times. Mike Lurch is also available. So if you're looking for other MakeHaven members to try and see who's around, the facilitator list, I think I might have to log in for, but there's a few electronics facilitators, so reach out to see what's going on. Ooh, Lisa asked a good question about what exactly is a servo. So a servo motor is a thing like this. This is the most common type of servo motor. They're really, really helpful for RC cars. So, and we'll go to Adafruit because they probably have a GIF to show what it is. I want to go to here. A servo motor like this, these are really common in like remote control cars. They do the steering, or in a remote control plane, they do the flaps for the thing to work. And so if we servo motor inside of an RC car, they get sold a lot with these little brackets. And so they can make things move. They have these little arms that let things turn, but it's a category of motor. And so there's the little tiny ones, there's bigger ones. They cover the gamut. And these are really helpful for making small actions occur. Yeah, and so that's what the servo library was about, which is where that came up. And if we pop back over to this thing and I close the code, this is simulating a servo, this little white horn thing, it spins and it's able to push and pull on the steering of a machine. So it's a lot of fun. There's a ton of cool things to learn with Arduino, but just getting started with understanding the code a little bit. We're obviously not going to become experts after a week or two, but just enough that we can poke around and make sense of it and ask reasonable questions is really, really helpful. So we're just dipping our toes into what this is, and you can go a lot deeper if you want. So, yeah.
Mentioned documents that you wrote.
Yes.
Are both of those linked in the chat?
Both of the yeah, the question was, I talked about documents that I wrote, and they're both linked in the chat. There's one that's like a big overarching document that I will say I sort of fizzled out at some point. But the 10 lessons, those I've been refining every year for 5 or 6 years. And so the ones that I have linked now that I put a folder in the Foundations chat for, those are the most refined, up-to-date versions that should be good to go and should not have any code glitches. So when you copy paste, as long as you catch all of the code in the blocks, it should just work out of the gate. And the documents have questions and things that go along with that. So if you want to follow through and just look at those, you can totally do it. My guess would be that without doing the screenshots and things, it'll probably take you 20-ish minutes per thing. And so it could be a nice quick week, and then you can get back to finishing things that you started this week if you need some more time. Which brings us to the exciting part of tonight. I'm going to stop sharing my screen. Let's do the stop share. And I'm really excited to hear about what are all the cool things that people did this week. It should be really fun to see what was up. I can start if we're here and doing this. I was working on, let me pop over to here. I need to make a change. Here's a camera that I can point directly at the project that I'm working on. So here's my setup, here's my laptop, and connected to that is this. This is an Arduino. And this Arduino is connected into this large piece of wood that I've got here on screen. It looks like it's mirrored. I hope that it's not, or maybe I've got something backwards. I'm not sure. But this is one big red oak panel that I made last year that I cut through with the Gerber to make these letters. My intent, and I polyurethane this week. So I've got a whole bunch of LEDs underneath this strip. And so these are all LEDs that I can individually control with the Arduino that's in there. And these are meant to simulate the control inputs for a button. So this is what it's laid out in is the circuit for a button. So this is a resistor, and here's the actual button laid out in LEDs. The goal is that I'll be able to draw in an animation with those LEDs to show off the circuit and how it works. Up here at the top, I've got this nice carved in button. My hope was that I would urethane and then paint that in. I'm going to get to the painting this week, I think. And then write in the code so that there'd be some big, these are arcade game buttons. So you press the button and it sort of is like you're pressing the big light up button. And then this is what happens if you don't include this resistor, because a common thing that people need to learn is what is this resistor for? And so this should, in hope, I'm a teacher, be a learning tool for how buttons work and like get a little bit more of a sense for hands-on, what does it look like? So that's what I was up to this week. This is more than 1 week's work. I want to be very, very clear. This is trying to finish something that I started a long time ago. And so it's got lots of CNC stuff, lots of Arduino things and stuff like that. So let's see, I'm gonna cut back to me. And yeah, we've got Two obvious choices for who to go first. We have James in the room and Renee on Zoom. Anybody want to wave and say yes, me? Okay, James is gonna go. Yeah, just come take the seat. We can point the camera at whatever.
So I decided that I was going to 3D design in Fusion and then laser cut out of plywood, kind of like a kind of toolbox, but also it's going to get changed a little bit so it can hang on my wall. And each of these little slots is for a specific tool or item that rolls around on my desk and gets in the way or is in like a mug or whatever. So, you know, Sharpies, precision screwdrivers, little EMT scissors, razor knife, etc. I thought it was super fun to like make something in Fusion that was just from my head. There was like no reference to anything except reality, which was pretty cool. But it did take me like 10 hours to figure out. It was pretty hard, and it took me like 30 minutes today laser cutting it and smashing it together, which was pretty anticlimactic, but it felt really good to do it.
That is climate. Like,
Yeah.
so
Right.
it took 30 minutes to get a quick truck.
Right. And like laser cutting it, I was like, oh my God, what if it doesn't work? What if it doesn't work? What if it doesn't work? And then it popped together and I was like, oh, look at that.
Yeah.
I guess I measured right. No glue. Yeah. So the whole thing kind of like fits together in slots and none of it is glued. It's all just like really tightly press fit together. And the plugin that I needed to use for Fusion is called DXF for lasers, if anyone is interested in that. And it basically, you can pick a flat body from Fusion and it will turn it into an SVG for your laser cutter.
That's fantastic.
Yeah, totally cool. So that's my project. Thank
Awesome. Very, very nice. That is a monumental piece of work to get started, to go from an idea to a real thing. That's what we're hoping for. So
Hey, James,
very
if you could throw the link to that DXF tool into Slack, we can pin it onto the laser channel. That's something that has planted a lot of people on their face over the years, trying to get from that DXF to a cuttable file.
For sure.
That would be a huge help.
Yeah, I absolutely can.
Yeah, it's really nice. It's a pretty, when you once, and we were chatting about that extension a little bit earlier. It's really not, it's not a super long process. It's confusing to get from the model to a thing, but this extension sounds great, and it figures out the kerf, right?
Bunch of different curve settings and kind of gives them it kind of gives some suggestions, which I went with and they worked. But I have a feeling you could really play with that and dial that in.
Yeah.
Pretty well.
Cool.
So yeah.
Yeah. So we'll share that, and hopefully it's really helpful for people to get it up and running. Awesome. Steve, did you do any cool things this week?
Aside from setting, I don't think you can see the grain, but like this is the frame I set on fire. Totally on purpose. Yeah, there you go.
Oh, that looks nice.
And it's cedar, so it smells like a Pacific Northwest
that's got a
salmon cookout.
That's got to smell good.
With that frame,
it is gonna. It's once I mount the painting, it's a little 6x6 canvas that kind of wraps around the edge. So I did a recessed mount.
nice.
Yeah, that's really cool. What's the name of that style? You knew the name right off the top of your head. The flame.
It's Shusugi Ben.
Yeah.
And you know, you can hit it with a wire brush and get like the really pronounced grain, but I kind of find that looks a little 70s to me. So I sanded it like I was going to finish it, and then toasted it, and then sanded it, really fine grain again. And it's it's nerve wracking.
Yeah. Yeah, but cool. I mean, that's
Yeah.
a really cool thing to have made. Definitely.
I think this is the first project I've done at MakeHaven where I have set it on fire completely intentionally, as opposed to working on the lasers where the unintentional flare up is all too common as well.
Yeah. That's got to be a new feeling for sure.
Very backwards.
But looks great. I can't
Well,
wait to
thank
see it
you.
in person. Tons of fun. All right, Renee, your camera is on. Would you like to share what you've been up to this week?
Sure. So I did not completely finish my project, but I made a lot of progress. I've still been struggling to find energy to do, basic things. So I've been struggling through a little bit, but I'll show you guys what I did do. Oh, I need to be able to screen share.
Oh, yep. That's totally on me. 1 second. Okay, you should be allowed now.
So I had
Ooh.
this eye that I punch needled. And so it's step 1, punch needle. And then you can see a little bit clearly here, like the recessed cuts that you have to make sure that it curves nicely around to the back. So this is the step where you're folding all the material around to the back and gluing it down so that you don't have, if you just cut it, you would have frayed edges everywhere and it wouldn't be clean and it would be crazy. So it's cleaner to just fold it and glue it. But at the bottom, I wanted to add a bunch of fringe, really, really long fringe. And I'd never done that before, but you can add fringe with a crochet hook. And I had this idea of this being this cool wall hanging with a wooden dowel and some straps at the top. So to add the fringe, you have to leave about an inch along the bottom to add the fringe. So I added all this fringe.
That's so cool.
Which took forever, but was really fun. And so yeah, the part that's left is I just need to attach straps to probably 2 places. I keep muddling over what is the best way to do this, and if I want them to be straps made out of yarn or if I want it to just be made out of cloth, and I just keep going back and forth.
That's a good.
Yeah. I feel like it could look good in a few different ways, but
yeah.
And then the integration part, I was really, really lazy on, and I was just the wooden dowel is woodworking, and I'll have to use a chop saw to cut it.
Yeah, no, that's totally valid. I was actually thinking, what I was wondering is if you'd want to put for the tops. I don't know how floppy those are, but when I do designs like that, sometimes the tops flop over for me. And so I wonder if a laser cut backing that just is for the eyelash part to hold them up so you could glue it to a solid backing if the punch needle isn't sturdy enough on its own.
That's not a bad idea. I think normally what I do is a felt backing. But I kind of like the idea of that to make it a little bit more sturdy. Yeah. So I mean that.
It depends on how you're gonna, what exactly you're going for. I was just thinking about it on a wall.
Yeah, that's nice. That's a nice idea actually. I might do that.
Cool.
But yeah. So that's what I did this week.
That's such a neat project. It looks really cool. I want it to have a partner so you can put 2 up on the wall. Yeah. It sounds like lots of fun. So cool. And if you ever feel like you want some support in coming into the space, doing stuff, let me know. I'm happy to connect the dots and run back up. So that's totally available. Just let me know. Yeah. Let's see. Lisa, you're unmuted. Do you want to tell us what you've been up to this week?
Okay, so before yesterday, which was, let's see, no, yeah, Sunday, which was the bulk of what I did. I prepared to take this big wooden slab that I have that was a cutting board with no features on it that my grandfather made 100 years ago, and wanted to work towards using the Shipoko to carve in certain things that will make it a carving board for like turkey. So it would have to catch the juices. It's called a juice groove and a Welland tree. So the first thing I did was go into Illustrator and design what I want this thing to be, make the vector paths for it. And that I could show you if you wanted me to screen share. I didn't take a picture of the end, where I'm at now because I was in such a rush to leave yesterday, but I could share what the
Sure,
path
yeah.
looks like. So don't I have to click on something to right,
There's
okay.
Yep, green share screen, then it's probably asking you which one.
Okay, let me find so this is representing what's on mic.
Yeah, it probably has got a few options of what screen to show. Yeah.
Okay. I guess I have a lot of stuff open. So that's not it.
I usually don't have a lot to hide, so I just go with full screen and go for it.
Okay, which is where?
Top left, probably the top left option.
Oh, that's just us.
Yeah, click that one. Click that one. It doesn't feel like it's the right one, but it's the right one.
I'm clicking it.
And then there should be like a go somewhere in the bottom center. Middle center. Middle.
Jeez, I did it last week.
Yeah.
Can I just like on my screen go to where?
Yeah, I might, we were talking about it and it might even be, oh, you sent me a file. I can open it up and
Yeah,
take a look.
Yeah, do that.
But
Because that's all I was going to
see.
show. Yeah.
And so open this. I'm opening the thing.
Because then I can explain what happened, what we did from there.
Yep, totally. And so let me share. Wrong screen, that one. Hit share. Okay, cool. So right now it's still got the thing, but now we've got, this is the general shape.
Yeah. So the board itself is kind of like a pill shape, but it's a 14.25 inches wide by a little over 30 inches long, and it's like an inch and a third thick. And I think it's maple or something hardwood, but it's flat. So I want to carve into it what looks like the tree shape, and then on the bottom that would be a recessed area point. Yeah, that where all the juices would flow into there, and also along the outer edge.
Yep.
So what I did was I bought some cheap pine wood and glued up a board of the same size, although, with no pill shape on it. It's just a big board, bigger than that. And then, brought it into
Carbide
create, and we created tool paths. I bought a bit of choice, an end mill that had a round tip to it, and I guess 54 minutes worth. We ran it. Well, if we started to run it, and unfortunately we didn't clamp it down hard enough. We thought we did, and it started moving halfway through. So there was that. But luckily I didn't care about the fact that I could then flip the board over and try again. So then we clamped it even better by gluing pieces onto the side of the board, butted up against the recesses in the in the bed of the Shipoko. Once we thought we really had it, firm, then we started to run it again. It didn't really run fully correctly because, I don't know, it didn't obey what we thought we told it to do. So I think we just have to I have to regroup and really figure out, because I really don't want to run it on the final piece of wood until I know it's going to work right. So
Yeah. I think that makes tons of sense. I'm so glad that we did a practice run on cheap wood that like is totally fine.
Yeah.
Because it slid, like as it's drawn here, it slid left to right.
yeah,
And that could have totally been the thing. One of the cool tricks that we saw was that we were thinking about how do you wanted a rounded feature here. And so you can do this like little offset where you go in by 0.125. And if you do this, you get sort of an inner boundary. We said that maybe that we could cut with a flat bottom bit, and then this outer periphery,
mhm.
you just do with a rounded bottom bit. And so you get a rounded edge and a flat bottom. There was,
And I think it would have worked. It just didn't do it.
yeah, no, it totally did. I think we got greedy in the toolpaths. We had like 5 toolpaths for it to do it all in one show. And I think it makes sense to go through and do everything with a flat bit and export that G code. And then it's totally going to stop. And then do another one where we export it with the round bottom bit for all the round bottom paths so that they're totally separate and it won't like automatically hop into the next thing, which it shouldn't do, but like whatever, it did. And there's ways to work around it.
Yeah, and I was doing a little searching on more YouTube stuff to see what people do, and one person cuts it with something called his tool is called a core box. His end mill or his router bit is a core box. Do you ever hear of that?
No, I don't even know. Like, I don't even know what that is. A quarter box?
No, core, CORE, core box.
Core box and mill.
Yeah, 3/4 inch.
Yeah. Oh, look at that. Yeah.
That's what I think I want to use.
That makes sense. Yeah, it's definitely hard to like wrap your head around what an end mill's shape and its cutout shape is going to be.
Yeah.
But I feel like we did a fair amount of this searching for different mills. So this is going to give you a fully rounded bottom where there's not like a flat at the bottom.
Right.
This looks like it would be great.
Yeah, and I could get several of them. So if you want to, I don't know, if 3/4 is just too wide to do the narrower parts, then make that tool path, with a narrower one. I don't know what these things cost though.
I mean, oh, well, that didn't work. But we can Cormax, ML, Amazon, right? Just do.
Yeah.
It'll definitely, we'll be able to find some sort of someone will be, nope, not that.
Mhm.
But we'll be able to find a core box and mill. Yep. Router bits. Here's this. Boom. A set of 1/4 inch shank.
Exactly.
So this is exactly what you want. $11.
Exactly. And so there's varying widths. We can, figure out what works for what part of it.
Yeah. I mean, here's a very wide ranging set for $28.
Yeah.
And so there's a bunch of options. It's always nice to learn a new vocab word. And so core box added to the list.
I learned it like 5 minutes before the class started.
Yeah, sometimes that's, you take the one when you get them.
Yeah.
Ooh, I do, just as a note, I do like this style where the cutting head is at least as big as the shank. These ones, this one makes me nervous.
Oh,
right?
sure.
Because you can only cut up to that shoulder and then you've got a problem. Right. So but if you need a 1/2 inch shank for your particular tool, this is a 1/2 inch wide down here. Maybe that's the way to go. Yeah. Anyways, I am very excited to see how this thing plays out when you cut your different heights, the yellow at one depth and the green at another.
Yeah.
I think it'll be
I don't
great.
know. I have to glue up another board, but I don't know. It was $20 to do this.
Oh, we can totally just flip it to the other side,
We did.
back again, or we can, that's a good point. We can plane it down
Okay,
so
good.
that it's flat. Yeah, we can plane it back down so it's flat again, and
Okay.
then you start from a fresh start.
Excellent. Okay.
Yep.
All right.
Cool. All
Okay.
right, I'm gonna stop the screen share and then we'll head back, see who's next up on the list. We've got Arvia and Norm. Either of you there? Ooh, Arvia came on with the camera.
Yeah, I just came on to say that I didn't get to do my project this week, but I was researching wood panels to do maybe, I don't want to share my screen because I'm going to show my photos, but I'll drop it in the Slack. I wanted to do the panels for the doors to the TV stand I'm going to make. And like on the CNC machine, yeah, I need to sit down and learn Fusion 360, or I'm assuming that's what I would use to make like a cool, like 3-dimensional shaped, I don't know, door panel.
There's a ton of options. Don't undersell. I mean, we haven't talked about VCarve at all yet, but VCarve is really powerful for those like pretty flat things. It does a really good job of that. And it's and you have experience with the Shapoko's VCarve toolpath.
Mhm.
The like VCarve software's VCarve toolpath is spot on perfect. Like Carbide Creates is fine. It's good. It's good. The VCarve one is really, I mean, it's their namesake toolpath and it deserves it.
So so this is, I don't know if you can see my phone. Can you see that?
Oh yeah, that's super
Yeah.
nice.
Mhm.
I mean, it probably won't be this nice, but I want to do something similar, or just be able to have like the grooves. So it's like not a completely flat panel. So I would use VCarve for that.
You could, there's a number of ways to do that. Those look like, it's a little hard to tell based on the size of the screen that I was able to see, but it looked like the edges of plywood sheets. And so some part of me wonders if I'm going to share my screen again, and I don't mean to keep overtaking things. And we'll sharing screens is hard. Screen 2, that one. Share. So this is Slicer for Fusion 360. And so in here we have all of these. This will let you upload a 3D model and then it will slice it into pieces. I'm now realizing that I don't have any 3D models on my desktop, but this will let you do, let's see, do I have any of my documents? Maybe.
Like a globe.
If I had a globe, I could, yes. Yep.
You get that next week.
And so if we come back to here, Slicer for Fusion 360, this is the software that will let you do this, right? So it's a really cool software. If you have something like that, like here's a rhinoceros that's a set of stacks. And so if you had that wave pattern, like here's a really cool bench that's that wave pattern all cut up. So there's some really cool options that you have if you wanted to do that design where you're designing the wave and then software takes it from that to like this cone that's just a series of rings where it's going to help you figure out some of the logistics of how you build that. This is one of our upcoming units, but we can totally hop to it early. It's a
Okay.
fun software that's like half unsupported, but worth figuring out the details.
Okay, yeah, maybe I won't do that yet then. Yeah, I've just talked to you on Thursday when I come in
Yeah.
about the ideas, because I was trying to find pictures and most of them were like that sliced effect. But
Yeah.
I thought about the piece that you said is in the apartment building and like how to do that on
Oh.
a small scale for like a panel of a door.
Yeah, no, that makes sense. There's totally there's some really cool options for building textures into panels that can be a lot of fun. So that would be cool. Yeah, and I would love to have the idea, talk it out with you, go through the logistics, and figure out what would be fun to make, because those installation pieces can be really cool. I think you were also featured on our Instagram this week for all the cool stuff that you've built in the past week or so, right?
Yeah, they put up I think the things I showed y'all last week, the Dylan sign and the record player holder, the record holder. Goodness.
That's,
Yeah.
you know, it's nice to get a little recognition.
Yeah.
So,
Thanks.
cool. All right. That's fun. And we've got Norm. Norm, you're unmuted. Are you around? What have you been up to?
Okay. Am I showing a screen?
Yes, you are.
Okay. So this is the problem I've got. I've got bamboo growing in the yard, which is lovely. It's evergreen and it's a good barrier to the view to the next door neighbor, but it runs. It's got an underground system of roots that are like wires. They're like rods of steel, very
Wow.
hard. And it's all one colony and it all powers the growth. So you have to contain it in April and May. And you can see it's got a very sharp line there because I've been attentive. I have it on my calendar. It's the beginning of April. I got to go out and start pulling it up, but it's like pulling up wire rods. And so I've never had the right tool. And I decided that I needed a tool that would be like a crowbar, but smaller. It would have a sharp hook, not a flat one for prying things out. It would have kind of a shovel in the end. And I got forge time at a place near my house. And this is the forge. This is actually an upturned wheelbarrow base this is a coal fire. It's a couple thousand degrees. And the tools are a hammer and tongs there to pick the stuff up. This little can is for cooling things in water when it's, and I'm a baby about COVID, so I don't like being inside if I don't have to. And this is a barn with open panels. They're not quite windows. You can slide them. To bring this fire up, they've got powerful blowers that bring it up the chimney. And then hammer and anvil. And at the course, which was largely kind of plus size guys like me, I found out there's a great Netflix series called Forge and Fire, which everybody knew and I didn't know anything about, but it's like the Great British Baking Show, but for guys who take tools and like they'll give you a suit of armor to cut up and turn into a knife or something. And everybody watched it, and the instructor turned out, because I had an instructor that helped me, was one of the earliest big winner contestants. So in any event, I took a steel, after like getting used to it, I took a 1/4 inch yeah, it's about a 1/4 inch, no, wait a minute. Well, 1/4 to a 1/2 inch steel bar and heated it. It has to be glowing red hot, then hammered it down with a hammer on the anvil. If you hammer along the edge, you can sharpen one end, which I did, so that it'll pick down into the bamboo. And I wanted it at not a tremendously sharp angle, because then I would have a hard angle pulling it over. By the way, this is a ruler, but it's 15 inches. So it's about 2 feet long. It's not as big as regular crowbar. Bent one side and then hammered down the other so that it both picks and pries and then sweeps the dirt away. And then because it's a project that's supposed to show different kinds of things, I said, well, what if I want a handle? And so I took a piece of wood and routed it. And there's a couple different ways you could route it. You could cut it in half and then route it, or you actually could cut both sides and and then route each side. Well, in any event, it's a long story, but I ended up routing it, thereby making a handle, which if I were to use it, would then be filed down so that it fits your hand. And so how do you support it? If it were a knife, you'd put like a rivet through it or something to hold it. But the whole point of this thing is that it's a single piece of solid forged steel that is the right size so that you can pry it up. And I'm going to use leather gloves and not worry about the handle, but you could make a handle, and there is a handle. I just would have to finish it. And that is part of what I did. And the other part of what I did was, maybe it's premature, but I was thinking about the project that we have to do. And I'm trying to find the tab here that I'm sure there's a quicker way of doing this.
Oh, you're all good.
Yeah, so this is what the problem is. This is my like little storage area, which my wife completely hates because it's totally junk everywhere. And a few years ago, I bought on eBay a machinist's cabinet that is really useful in a different part of the house, also junky because that's the way I am. But I kind of thought that if I had one or more nice cabinets up here, I could put all the shit into this thing. And I could actually even make it nice. And I was thinking that the top, I could have inlays with acrylic laser cut seams of the water around here. I could do metal surrounds there, but with nice enough wood, I might not. I thought about doing 3D printed knobs for the pulls, which you could do. There's a Green Man design I found that would be kind of, that's sort of like a what do you call it? Some kind of a creature, a gargoyle that the people put in gardens sometimes. But I think just a really nice piece of turned wood on the wood lathe would be good. But you know, if this is workable for a project, and then the whole case, they call it, I think, a carcass, the outside would be a thing I don't know how to do, that would be its own project, particularly if I did something like, you know, joining it. These days I would just, this example, it's screwed together. You could conceivably, you know, put dowels in it, or you could put fingers, or if you were super smart, you could do, what do you call them? Those
Dovetails, maybe.
dovetails.
There's also we got a domino tool, which you can do now. That's a new addition.
Yeah, and I know there's a jig for dovetails, but the thing is, this is an infinitely expandable project. I can make it as complicated as I want, and I can make more than one, and I need more than one, really. So I'm hoping that would be suitable as some variant of that would be suitable as a final project, because I've already started. I've got on the shape. I went on the Shape Poco, and I started doing pockets for acrylic inlays and things, and I got in the lathe to do knobs, and it's kind of cool. Once you get into it, there's kind of no end to the tools that suggest themselves that you might work on. So in any event, that's what I've been up to.
That's a ton. Really cool, Norm. I'm fascinated about that you got forge time. That's
I've got some forge time this weekend too. My plan is to next week show, you know, like I didn't make a handle for this because I really don't think it needs a handle, but a knife needs a handle. I'm going to make a knife and then make a handle.
Oh, cool. Yeah, that's awesome. Super cool for what you're doing. And I think that machinist chest or making something like that that's perfect for your scenario would be really cool for a final.
And I was looking for models of machinist chests. I know you're from Ohio. The big place that makes the best machinist chests is Gerstner in Ohio, and they cost a fortune. They've got factories in Asia that make cheaper versions, but they make a big deal about them all being made in Ohio for the good ones, and they're beautiful. But you could spend $1,000 in those things. So I'm planning to, instead of working this year, I'm gonna make chests for myself. It'll be non-taxable income worth a ton of money.
There you go. Sounds real. Sounds totally reasonable. And if you get good enough at making high quality chests, you can absolutely sell them as like a one-off artist piece without a problem.
Well, you can sign up now. I'll take Bitcoin or whatever. I do want to say that Kate also uses this, or not, one of the instructors at the metalwork place, also known as Kate. So I've talked to her about that too.
Oh, yeah. Yeah, there's tons of cool potential. And I think especially if you build those cases and then you build them out to be so totally custom, that's going to be a really fulfilling final project. And even if you want to get super fancy, you could add in like lights, so when you open the drawers, it lights up, or however.
Yeah, I thought about that because you're because the whole course has got all these things. You're like putting the 3D printed stuff on it and the LEDs. Yeah, I thought about that. But the thing is, if I have really nice materials, what I'm going to do is I'm going to do one version that's just nice materials. And the knobs, I could do 3D printed things that'll go over them if I want to do that. There's metal surrounds that I can do around the knobs, but I don't want to distract from, I've got some nice bird's eye maple that I don't need to cover up with brass. But another version of it, I would want to cover up. Plain walnut with brass might look great.
Yeah, no, and I think that really hits at a truth of the transition. Like there's definitely projects that I've made where I don't care what it looks like, and the finish on a 3D print is fine, and like it can be exactly what I want for shape, but not perfect texture. But when you're trying to make something that is really, I'm gonna say artisanal, you want to have the right materials, and that makes a big difference. And so making those choices strategically could be really helpful. Like you may not want to have 3D printed handles, but when we get to molding and casting, it could be useful to 3D print something and then make a mold, and then you could cast it out of some other material if you wanted to do that.
I love that idea.
I did some casting pewter last year, and it would be lots of fun to get some high temperature silicone, and you could cast pewter handles for that like you've made yourself.
I'd love to
the problem. Yeah. It's very doable. Pewter's super fun to work with, and it's not that expensive. The thing that got me last year was I didn't buy high temperature silicone. I was under committed to my particular craft that I was trying. But I would happily split the price of some high temp silicone for pewter casting if you wanted to do that, Norm.
I'm all in that. Yeah.
I have a ton of pewter if anybody wants to buy some.
Oh, there you go.
Pewter smith, so I have sheets and sheets, and I have scrap and everything.
Oh, that's great.
I'll sign up.
Let me know.
Hey, Norm, if you're doing that laser inlay, you might also want to think about mixing a little bit of epoxy resin work in there instead of the acrylic, because you can get incredibly fine detail, basically, because you're pouring it on and letting it set and then sanding off the excess. So you can get flush, and you can get, so you're not actually trying to, fit precisely into a piece with a cut. It's, you're just pouring in and letting it set. I'd be happy to talk to you about that sometime. I've done a bit of that.
Well, so that's interesting. So far, what I've done is I've done some really nice sharp laser cuts into, it seems like there's different kinds of acrylic, and some cut better than others, but clear acrylic produces a really nice white thing. And I've got a couple scenes of local areas, but then, so how to cut it into the medallion shape that I want in the Shapeoko.
Oh, okay, I see what you're doing. Yeah.
I was using the scroll saw to cut it down, and that seems to be okay. It doesn't seem to hurt the blade. You use the right blade, of course, or you could cut it by hand. I used a jigsaw to cut some of the stuff, but it's a rough edge, and I'm thinking of filing it down to make it fit. The resin approach I hadn't even thought of.
The resin can be.
Yeah, I mean, you wouldn't be able to etch in a scene, but you'd be able to, if you were doing like inlaying text or something, it'll make your life a lot easier.
Well, like the Green Man thing that I've got, I've got a vector file for a Green Man, and maybe I could do, I mean, I'm getting ahead of myself. I don't know these tools or the mechanisms or anything, but I like the idea of molding stuff.
Yeah, there's tons of cool options. There's still a ways to go. We've got lots of cool things that we haven't even explored yet. And I think that you're really gonna like the idea of an epoxy inlay. Sounds like a lot of fun. The inlays that you're talking about for acrylic, there's a part of me that now that Steve says that aloud, I would say, if you're going to go to the trouble of inlay, I kind of want you to like water jet and have a nice piece of sheet metal or some like material that's hard to get some other way. If you're going for a plasticky look, you might have a better experience with the epoxy because it just floods in the areas that you've cut on the Shapeoko.
Well, I'm thinking of doing more, you know, I don't know how many boxes, how many chests I would make, but I could make X number of lids different ways with different inlays. I can make different kinds of knobs. I could actually even disassemble them and put them back together again, possibly. Although part of it is the practicality of having storage. Actually, it's very useful for me to have storage. It's and to tell you the truth, the little crowbar I made, that is going to be very useful to me. It's a, you know, it's not pretty or anything, but it's different from what you could buy, and it's really useful to me.
Yeah, that's the maker dream. You're doing it, Norm. We're just trying to live up to the example you're setting.
Living the dream. Yeah, that's it.
Yeah, totally. All right, that is cool. I am super excited about the projects that you've all taken on. It's real cool. We ran all the way to 9. This is a long week for us. But I'm super excited to have heard about all the cool stuff that people made and to keep it going. This week with programming on Wednesday, Coleman will be around. I'm going to be around on Thursday and then Sunday. If you want to go it alone or go off course or try and program an Arduino, use an Arduino to program just a bare chip, all of that is totally possible. But the big thing I would say for most people is probably going to be to try and follow those lessons and see where they take you and how that feels. That's my suggestion. So with that, it was really cool to get to hear about everybody's experiences and to see what that was and to collaborate around all of that in any way possible. I would, the big thing was about integrating. And so hopefully you felt like you got to integrate a little bit. You got to feel the pressure of what it's like to try and work within a week, which is a short time frame. And we're gonna get back to it. We're gonna learn some more new skills and you'll have more chances to integrate things again in the future. So great to see everybody. We'll see you in the space and have a great week.